This video is a continuation of the control flow notebook, and we'll discuss while and for loops. The while statement is used for repeating a block of code as long as a conditional expression evaluates to true. So you can see here in the diagram that we first check a condition, and if that condition is true, we execute the block of code making up the loop body. Once the loop body is finished, it loops back and rechecks the conditional expression. The loop continues in this fashion until the conditional expression evaluates to false, at which point the interpreter will continue on with code that follows the loop. This is actually similar to the if statement, except in the case of the if statement, we only evaluate the body once if the condition is true. So as an example, we're going to use a while loop to output a subsequence of the Fibonacci sequence, specifically only those values that are less than 10. So the Fibonacci sequence is a sequence of numbers such that each number is the sum of the previous two, and we define the first two Fibonacci numbers as 0 and 1. So in this code, we're going to use the variables a and b, where a will be the current Fibonacci number and b will be the next Fibonacci number. And to start, we're going to initialize a to 0 and b to 1. Notice here that I'm using the comma operator to perform multiple assignment. So in this line, the variable a will be bound to the value 0 and b bound to the value 1. Now, to create a while loop, we start with the while keyword, followed by a conditional expression. And since we want only the Fibonacci numbers less than 10, we're going to say a less than 10, since a is going to contain the current Fibonacci number. And then, just like an if statement, we're going to end this line with a colon. For the body of our loop, we're going to print the current value and then update both a and b to the next values in the sequence. So to print the current value, I can write print, pass the value a, and then I'm going to use the end argument. If you're unfamiliar with the end argument, feel free to use help print to view the built-in documentation on print. But for the end argument here, I'm passing a string containing a comma and a space. So in the output, our Fibonacci sequence will appear on the same line with a comma and space following each value. So now in our loop that we've printed out the current value, we need to update both a and b to the next values in the list. So to do this, typically you need a temporary value to store one of the two variables so that you don't overwrite it and accidentally use the wrong value. What I mean by that is we could write something like the following. We temporarily assign the value of a to a variable t. We then update the variable a using the variable b. And then we update the variable b using the temporary value. So now after these 3 lines of code have run, both a and b have been updated to the appropriate values. However, we can avoid the use of the temporary and make this code a little cleaner if we use a multiple assignment. So I'm going to remove this and write a comma b is equal to b comma a plus b. And this works exactly as you expect. All the expressions on the right-hand side are evaluated first, and only after they complete do the assignments occur. So now, if we run this block, we see that we get the values 0, 1, 1, 2, 3, 5, and 8. We can easily verify that every value here is the sum of the previous two, and none of these values are greater than 10. And since our print statement printed only a single value at a time, we can see that the body of our while loop ran a total of 7 times, once for each of the values here in the output. And the execution of the values stopped when the value of a was no longer less than 10. The for loop is similar to the while loop, except that it executes its loop body once for every element in a sequence. If we look at the diagram here, given a sequence, which could be a loop or a string or even an object that generates elements on the fly, for every element in the sequence, the loop body is going to be evaluated once. And after the loop body finishes, we're going to loop back and get the next element from the sequence. I should point out here that quite frequently, the element itself is made available to the loop body for processing of some sort. And we're going to see some examples of this in just a moment. But when the sequence is exhausted, meaning there are no more elements, the loop body will not be executed again, and the interpreter will continue on with any code that happens to follow the loop. So let's start by creating a sequence. We're simply going to declare a list of strings. And then to write a for loop, we start with the keyword for, followed by a variable to which the current element in the sequence will be bound. And then we use the in keyword, followed by the sequence itself, and finally a colon. And the loop body is written just as it was for both while loops and if statements. And for this example, we're going to print the word from our list, followed by its length. So we're going to write print, pass the variable w, and then we're going to pass the length. And when we run this block, we see that our for loop has iterated over our list of strings and printed each string and its length on separate lines. Now, in previous sections, we used the in keyword to test for containment. And this usage is conceptually not that different, but context is going to allow you to differentiate between these two uses. Similarly, since the for loop just expects any sequence, we can actually iterate through the characters in a string and print each of its characters one per line. So if I write for letter in the string mountain, and then for the body I write print letter, you'll see that we get each letter in the string mountain printed out one per line. The range function allows us to specify a range of integers without explicitly allocating memory for each of those integers. And this is really quite useful, say we wanted to iterate over a very large sequence of integers. Now, for example, if we wanted to iterate over some small set, like the integers 0 through 5, and then print out those values and their squares, I could write a loop as follows. For I in, then we're going to use the range function, pass the argument 6, and then for the body, we're going to print the value of I, followed by a string that says squared equals, and then give it the squared value. So I asterisk asterisk 2. And in the output, you see that we get the values 0 through 5 and their squares. Now, the range function has several options for its arguments. And if we give it a single integer, as we did here in this example, it will use that value as the stop value and return the range of integers from 0 up until that stop value, but not including the stop value. And this is why we gave the value 6 here, but we only see the values 0 through 5 in the output. Now, if we wanted to start at a value other than 0, we could do so by passing two arguments to the range function, where the first argument is the start value, inclusive, and the second argument is the stop value, exclusive. So if we write for I in range 4 to 10, and then simply print the values on a single line, you'll see that we get the integers 4 through 9 in the output. Now, similar to slicing, we can specify a step value as well. So we can march from 0 to 10, say, in steps of 3, by saying for I in range, 0 for the start value, 10 for the stop value, and a step size of 3. And when we run the block, you see we get 0, 3, 6, and 9. And we can actually do this with negative values as well. So now, let's say you wanted both an element from a sequence and its index within that sequence. To do this, you could use the range function coupled with the length function. So let's first create a list of strings to work with. Then for our for loop, we can say for I in range length of a. And this will give us the set of integers from 0 up to, but not including the length of a. And we'll use these as the indices of our values. In the body here, we'll say print I, the index, and then we're going to index our list A with A bracket I. And now when I run this, you'll see that this allowed us to operate on or use both the element and its index from within a loop body. But as this list says, this is not the way. A better way to do this is to use the enumerate function. The enumerate function takes a sequence as an argument and will return both an index and its corresponding element when iterated upon. So in our for loop, we can use multiple assignment for I comma v in enumerate a. And then once again, we'll just print the index and its corresponding element from the list. And you see here that the output is much the same as it was in the previous example, but this code is much cleaner and easier for someone to see what's really happening. Now, we've used the range function just as we would use a sequence, and I stated that when we started this section that we use this function when we want to specify a range of values without actually allocating each of the elements up front. So if I were to just print a range, you don't see a list or anything like that in the output. You actually see a range object. Now, the range object is iterable, meaning that it's capable of returning or generating its members one at a time until exhausted. So while this is not a list, we can use it anywhere that expects an iterable object. For example, we can pass it to the sum function in order to get a sum of the values between, say, 0 and 4. So you see in the output here, we get the sum of 0, 1, 2, and 3, which is 6. In the event you did need a list of integers, we could still use the range object, but we'd have to pass it to the list function to create that list containing the integers in your range. So if I say list of range 4, you see in the output we get a list containing the elements 0 through 3. And there are actually a host of uses for this function, and you're going to see it again in future sections.